So 9.6, I think this is where the chapter switches over just to volume. And so we're not doing surface area anymore in this new section. We're doing volume. And kind of like before, we did surface area of this type of shape. Then we did surface area of a different type of shape. We're starting now with just rectangular prisms. So basically, we're going to have our 90-degree angles. In a prism, you remember, the two bases have to be parallel, and they have to be congruent, so identical. So this one here, you could say this very bottom edge here is one base. Then this top part here would be a second base or something. Is that fair for you guys? So that's kind of what we're talking about with these rectangular prisms. So 90-degree corners for this. For one like this, if you look down at example one, what's the equation that you use all the time for that? Volume is going to be length times width times height. So that is pretty much the equation that people are going to use over and over and over. I want to show you the other equation that the book talks about in this section. And I'd maybe do this. And I don't know if I'd write this. It might just confuse you. But length times width. Do you agree that's going to be like maybe the 30 times the 22? Yeah. If you were to do 30 times 22, what does that actually tell us about this picture? It tells us the what of the base? Area. Do you agree if you do that 30 times the 22, it tells me the area of this chunk right there? Yeah. So what they've done now is our second equation, they take the area of that, and I've been throughout this year trying to convince you guys to go and always use lowercase letters for these side lengths, because what they do is they say, all right, I'm going to put a capital B here, and then that's going to be my length times my width. My capital B stands for the area of the base. So the second equation is going to be V equals capital B times H. And you could say where capital B equals the area of the base. And I'm kind of jumping the gun a little bit, or perhaps our book is jumping the gun a little bit when they try to teach it to you this way, because really, we don't need that. Honestly, I think this top equation is easier, just length times width times height, what you've always been doing. But the reason I mention this now is this is the equation you're going to start using in a future section when now we're trying to figure out the volume of, say, like a soup can or something like that, and I kind of killed it a little bit. Well, do you agree you could find the area of the base and then put that in for this capital B? And when you multiply by the height, what you're really doing is we're saying, okay, there's a certain number of maybe square centimeters in there. Fair enough? And if you know that this thing here is 12 centimeters high, it's kind of like you're saying, well, I have a certain, it's hard to do it like with the drawing, but I have 12 layers that are 1 centimeter high. So if I know how many of these like square cubes are in this bottom area, do you agree multiplying by 12 just tells you how many square cubes are going to be in these 12 layers of cubes? So it gives you the volume from the area. And if that just totally went over your head, don't stress about it. I'd be glad to talk with you about it if you want. But okay, let's just go ahead and do it the way we should, this section. So I can't erase anymore, which is going to be a problem. So we'll just squeeze in right here. Why not? So volume equals, I'm going to do length times width times height. Is that what you want? Mm-hmm. That's, yeah, I'll use that one. You could do the area of the base, but it's the same thing. All right, length then we said was 30. Now I'm going to leave off units in here. Width is 22. Height is 8. And those are all feet. So when we get done, we're going to have a volume of 5,280. And if all of those measurements are in feet, and we just found the volume, it's going to be 5,280 feet. Anyone? Cubed. Cubed. Yep. So area is always going to be squared. Volume is going to be cubed. So final answer, 5,280 feet cubed, or these little cubes that are 1 foot by 1 foot by 1 foot.
Why don't we just put it through?
Okay. So then I tried doing this. My basement, the height's kind of low in my basement, and that's kind of where this comes from. So I have no idea about city ordinances. I just made that part up. But say you have a city ordinance. You want to dig out a hole in the ground you're going to put your basement in. Fair enough? And let's say the city ordinance says you can only remove that much dirt for your basement. So I want to say, well, how deep can my hole be if I want to keep the same length and width, so I want to still have 30 feet by 22 feet for my basement, how deep can it be and still have that volume? Fair enough? Well, I'd start with the equation, because you know me, I'm always trying to get you to do the equation, right? Volume equals length times width times height. Where do we put some numbers?
I got it.
Where does the first number go? Actually, I probably should keep the picture.
4,950 for volume.
Perfect. Volume is 4,950. Great job, Jack. Should I put in units or leave them off?
Just leave them off.
I'll leave them off. Okay. And now our length is going to be 30, and width is 22. And it doesn't really matter which one you call length and which one you call width, but the height, or kind of the depth of our hole, is the thing that we're still trying to find now. And you could go through and do this in 2 steps, divide both sides by 30, then divide both sides by 22. Personally, I like combining these together into just one number. And multiply those, you're going to get 660 times h equals 4,950. So if I want to solve for the height now, what do I do to both sides?
Divide by 660.
Perfect. Divide by 660. And the height, or in this case, kind of the depth of the hole, ends up being 7.5. 7.5 what? Feet. Yep. Because it's just going to be a length in one direction. And where we had cubic feet here, feet times feet here would give us like square feet. So if you wanted to, you could look at it as though it's feet times feet times feet, feet cubed, divided by feet squared. You're only left with 1 foot at the end. Or more normal people just say, well, I just found a distance. All the distances here are measured in feet, so they go with it. All right, we okay with that one? Then, remember doing crazy areas? Now we get more exciting problems. We get to do crazy volumes. So I want to hack this baby up into shapes that we can easily find the volume of. And then when we're done, we add them together.
Okay.
When I look at that, I think either you cut it right here or you cut it right there. Which one do you guys want to do?
Hold on.
Down.
I just want to see something.
Cut it horizontally? Okay. So I'm going to take and cut this thing like so. And you could try to draw in all the little parts if you want to, but I'm going to cut it like that. And then we have, what's the volume of this top part? Maybe volume of the first thing. Length times width times height. All right. Do you want to call maybe this side the length? That front edge? Doesn't really matter. You just multiply them all together. But what's that length going to be? 8 inches. Perfect. People got it from that, I'm guessing? So 8 inches. My width then I'm going to say is that right there. That has to be 7. I like the 7 inches. Because we know this whole length here, this whole thing is 16. So do you agree this whole thing is 16? But we know this is 9. So this part's 9. So if you do the whole thing, the 16 here, take off the 9, then you have just what's left, that width. Agreed? All right, let's see if I can get rid of all my hacking up the problem. So 7 inches. Now we just need the height. 4. Nice. Pull that from right there. So 4. So 56 times 4. So 224. I guess I could have put inches there. Units are going to be inches cubed because it's a volume. So that's our first number. Now we could get the volume down here. So could do a V2 for second volume if you want. Doesn't really matter. But it's length times width times height. Somebody give me some numbers.
16, 8, and 6.
Perfect. I'm going to put 8. That kind of matches what we did before. And 16 and 6. I punch all those in. I get 768. Yeah, they'll add up to the same thing. It doesn't. I didn't want to confuse people, but maybe I just made it worse. So, all right. So now we have this one. Total volume. We take those two numbers and
992.
add them together. So plus 224. And you guys said it was what again?
992.
Okay, perfect. 992 inches cubed. So really it's the same things we did before. We just now are doing it in volume. Any questions?
No.
No.
Easier than surface area, you think?
Yeah.
I agree. So it'll be nice. So.